Okay, in this video we're going to be looking at taking what we did in the last episode and adding a potentiometer to it. Now, a potentiometer is, think of it in terms of a variable resistor. So essentially it's going to change the voltage that passes through it depending on how it's set. Now, we can use that variable resistance to our advantage when we want to set up a delay for our blinking lights. So what we're going to be doing is basically setting up a simple circuit for the potentiometer where basically we're passing voltage through it, and we're also taking a measurement from that based on the other pin, because a potentiometer is made up of 3 pins. So if we have a look at the final result here, you can see this is what a basic potentiometer looks like, and there's actually 3 pins on it. It's got 3 legs. It's a little bit hard to see there, but when I show a picture of clear a picture of them, you get a better idea what they look like. And so I've got a red wire, a green wire and an orange wire going to it. So the red is the positive, the green is the negative or ground, and the orange is what we're going to be taking the reading from. Now, if I take a small screwdriver and adjust this potentiometer, you can see I can actually increase or decrease the speed of the flashing light. So I can take them right down, you know, almost like a railway crossing or something like that, right up to a pretty quick succession, almost to the point where they almost look as though they're both on at the same time. So it gives you that extra control that you can tweak just with a screwdriver, as opposed to having to go into the code and changing it all the time that way. So the first bit is for me to show you the setup of this. So I take the prototype we did from the last episode and I'll show you how to set up the wires. Then of course we look at setting up the code and uploading that to the Arduino. Here we have our circuit from the previous episode, and all we need to set up our potentiometer system is of course a potentiometer. So this is what they look like. Now this is a 154, I think it's 15 kilo ohms if I remember rightly. So I'll put up a picture. You can buy these dirt cheap. It actually doesn't matter what type of potentiometer you use for this particular project. You'll see different types of them. Some of them are quite large, but essentially it doesn't matter, because what we're doing is we're just going to be measuring the difference in the voltage going through it. So it doesn't matter what potentiometer you get your hands on, it'll still work the same way. So we can see the potentiometer's got 3 legs. So the 2 outside legs, we're going to be running a voltage through those. And the middle leg, we're going to be taking a measurement from it. So what we're going to do is we're going to plug this in. And again, I'll show a fritzing diagram at the end of this sequence, just so that you get a good idea of what it's supposed to look like. So what I've done is it goes over essentially 3 lines, if you like. But I've basically just plugged that in. Now this one's got a bit of solder on it still, because I salvaged it from some old electronics, so it's not sitting in completely flush, but it will still work fine. So the first thing we're going to do as far as hooking this up is we're going to be looking at the measurement pin. Now in the last episode we looked at using a number of digital pins. This time we're going to be looking at using one of the analog pins. So these are the ones that are have the A in front of them. And what I'm going to do is I'm going to pick a random one. Let's go with A2. Okay, so I've just connected a jumper lead there to A2, and this will go to the middle pin of the potentiometer. So this is where we're going to be grabbing our measurement from. Next thing, we need to pass a voltage through this potentiometer so that we can read it as it changes. So even though this is powered by USB, this Arduino, it actually has a couple of pins that will provide a set voltage. So if we have a closer look, you can see there's one here that has 5V, which means it will output 5 volts to that. So what we're going to do is we're going to hook into that 5 volts and we're going to apply that to one side of the potentiometer. Okay. And then of course, in order to complete the circuit, we need to have the other side of the potentiometer, so the third pin, we need that to go to ground. So again, we're just going to go to our ground rail. So you can definitely start to see now why it was advantageous to have these rails set up on these prototype breadboards, so these solderless breadboards, because that way, if as long as you've got your ground connected from your Arduino to that rail, every other ground you need can just go to anywhere along that line. At the moment, if we plug in the USB, all you'll get is just the flashing 2 lights. You won't be able to change it yet. Of course, we need to update our code. So that's what we'll be doing next. We'll be updating the code and uploading it to the Arduino, and then we should have a finished prototype. So here we have our code from the previous episode, and what we're going to do is use this as a basis for the update with the potentiometer. So we're going to leave our first 2 variables the way they are. So we had one LED on pin A, one LED on pin 6 and one on pin 11. So we're going to leave that as it is. But what we're going to do is we're going to get rid of this LED delay, because we're actually going to be using our potentiometer to determine what the delay will be. But instead, we're going to create a couple of variables to do with the potentiometer. So the first one is going to be the potentiometer pin. And if you remember, what we set that to was A2. So that was analog pin 2. And the next one we want to get is, as we turn the dial on the potentiometer, we want to get some sort of value out of that, because that value is going to determine the delay. So again, we're going to set our variable to an integer, and this one's going to be potentiometer underscore value. Now you can shorten these variable names. I just like to keep it sort of reasonably verbose when I'm teaching this stuff. Now with this one, we're not actually going to set it to anything. So you may choose to have a start value, but it's not going to matter, because as soon as the code runs, it's actually going to be looking at whatever value the potentiometer has. So we're not going to set it to an initial value. The next thing we have to do is look at our pin mode for the potentiometer pin. So this is where we do something different compared to what we did previously. So I'm just going to copy the potentiometer pin, variable name, and this time we're going to set it to an input. Because if you think about it, what we're doing is we want the potentiometer to determine how fast these LEDs are blinking on and off. So we've set up, we've initialized our pins, we've explained to the Arduino, which ones are outputs, which ones are inputs. The next thing we need to do is we need to find out at any given time, while the Arduino is looping through, what the value of the potentiometer is. So what we're going to put at the very top of the loop function is potentiometer value. So I'm just copying and pasting, equals And this time, because we're talking about an analog pin, we actually need to use a term called analog read. And of course, when we're talking about analog read, we need to tell the Arduino which pin it actually needs to read the value from. So of course, in this case, it's the potentiometer pin, which again, I'm just going to copy and paste. So we're going to get our value from the potentiometer. The next thing is to apply that to our delay. So I'm going to copy the variable name here, potentiometer value, and I'm going to replace our old lead delay with this potentiometer value. So whatever the potentiometer value is, that is the delay in which the LEDs will blink on and off. So instead of having to go into your code all the time and adjusting that delay, now we've set up the code so that you can do all that tweaking just with a screwdriver. You don't actually need to sort of update it. So that's essentially code for setting this up. We need to verify. So we're just going to check our syntax. We need to plug in our Arduino board to our computer. Go to Tools, just check that we've got the right board selected here, and then of course we need to go to Upload. And depending on where your potentiometer is set to, your lights may be blinking very fast, very slow. They might look as though they're constantly on or constantly off. The next step is to adjust that potentiometer just to ensure that it's working okay. Okay, so we've uploaded the code to the Arduino, and now we can experiment with adjusting the potentiometer. And you might find it'll be quite, in the case of the potentiometer I'm using, you only need to give it a very slight turn. You don't need to overdo it. So it depends on the potentiometer you use as to how much you need to turn it to adjust the speed. So if I want to go a little bit slower, so it's more like a railway crossing. So it just gives you that that extra added bit of control. So the next step with this prototype is to solder it, put it together, and basically set it up so that we could use it in a scale model. Now, of course, if you wanted to set up, say, like emergency vehicle lights, you're not going to be able to fit this whole array into the light system on the top of a car. So you've got to think about how you're actually going to manage it. Now, normally what I would do in this situation is I would actually solder all this up onto a small board, and then I would have that and the Arduino sitting either in the base, or if I could actually hide it somewhere in the model, if the model was big enough. And then I would run wires through the model into the LEDs. So at the moment I've got it all close together here, but when you think about it, all you need to do is all the main electronics you can have in one part, hidden away in the base or inside your model somewhere, and then wires going to the LEDs that it's controlling. So you don't need to have it all close together like this. This is purely just for prototyping. So in the next episode, we'll start looking in a bit more detail about soldering. I'll be talking about what you'll need in order to sort of solder this all together, and then the sort of things you need to consider when you're putting it inside your kit. So that'll be the next episode. We'll see you then.